Welcome to Introduction to Relations and Functions. A very important definition in this section is what is a function and what is not a function. A function is a relation between two variables, the input, and it's often named as x, and the output, and that's often referred to as y, where for each x there is only one y. A simple way to check if what you see is a function is to, number one, check if you have the same inputs, so same access, same inputs. If you do not have the same inputs, it's a function. If you do have the same inputs, then you ask yourself the second question. You check if those same inputs have same outputs. If they do, it's a function, and if they do not, it's not a function. So let's go ahead and look at a few problems that ask you just that. Is what you see in front of you a function or is it not a function? Here are the first three questions, and all of them ask you, are these functions or are they not functions? So your answer should simply be yes, it's a function, or no, it's not a function. Remember the steps of checking. Check if you have the same inputs. If you do not have same inputs and the inputs are the axes, these are your inputs. If you do not have the same inputs at all, it is a function. So let's go ahead and check if we have the same inputs. We got 2, 5, 6, 7, and 9. We do not have the same inputs. So if you do not have the same inputs, it's a function. So yes, a function. Let's look at number 2 here. Again, you got your x column right here, and those are your inputs. So again, let's go back to our steps here. Check if you have the same inputs. Do we have the same inputs? Well, looks like we have 2 of the same inputs, 2 negative 3's. And if we do, then we go to the second step. And the second step says, check if those inputs have same outputs. So what are the outputs for those negative 3's? Well, the first output is a 0. The second output is also a 0. And if they are the same, they do have the same outputs, it's a function. So if these zeros were not the same, you would say no, it's not a function, but they are the same. So this is a yes. Last final one for number 3, same steps. Now the look of it is a little different. It's points or ordered pairs. So this is your x and y, and then another x and another y, and this is the next x and the next y. Your x's are still your inputs, and as your first step in determining if this is a function, you are checking if you have the same inputs. So these are your inputs, and looks like we have the same inputs right here. The next thing is to check if those inputs that are the same, so our 2's have the same outputs. The first 2 has a 15, the second 2 has a 1. They have different outputs, so it's not a function. Now, the next 2 very important definitions are a domain of a function and a range of a function. Okay, so the domain is a collection of all inputs. Those are your x's, all of your x's. And then the range is a collection of all outputs. Those are your y's. Here is a picture of a few points on the coordinate plane, and the question is asking you to give the domain and the range. Now make sure you go back to the definition here and recall that the domain is all of the axes of whatever it is that you have, whether it's a chart and you pull all of the axes from the chart, or it's a few points and you pull all of the axes from the points. And here we have a picture, essentially points, but you kind of have to determine the x's and the y's of those. Um, so let's look at this first blue point on the left. The coordinates of that are negative 2, 1. Next one here is negative 1, 0. And then the next one following here is 1, 2. The next one is 2, 0. And finally, 3, negative 3. Okay. When we're asked for the domain, we just pull all of the x's of those points. So negative 2, negative 1, positive 1, 2, and positive 3. And then for the range, we pull all of the y's. Those are, and I'm going to go in ascending order, so from smallest to largest, negative 3, 0. I have a couple of zeros, one here and one here. You do not need to list both of those, just list at once. And then positive 1 and positive 2. That's your range. Another important piece of information for this section is what we call a function notation. A function notation is when your function is given to you as an equation, and instead of y, you will see something different, not a y. For example, sometimes an equation of a function may look like this. In fact, you're very familiar with this equation. It's y equals mx plus b, so it's just a line with the y-intercept of 1 and the slope of 2. The same exact equation in function notation can be written as follows. If you compare the two, you will see that all that changed is instead of y, I now have f of x, and that's how you read it, f of x. It's short for a function of x. If that's confusing to you and you see f of x equals 2x plus 1, please be mindful that you can always write it simply as y equals 2x plus 1. F is not the only letter that you may see in function notation. The same equation can be written as h of x equals 2x plus 1, or p of x is equal to 2x plus 1. Sometimes you may see k of x equals 2x plus 1. So f is not the only letter for a function notation. G of x is a common one. So if a function is given to you in a function notation, you will most likely be asked to evaluate the function. So this first example gives you the equation in function notation, f of x equals 3x squared minus 2x plus 4, and it asks you to find f of negative 2. If you compare the notation f of x and the notation f of negative 2, you'll notice that the change there that happened is the x that used to be inside of the parentheses is now written as negative 2. What you're asked to do is to replace every x in your equation. So wherever you see the x, you see it twice here, with the negative 2. So to find f of negative 2, you will write the equation over, and nothing changes except every single x turns into a negative 2, the number in the parentheses here. So this x here became a negative 2, and the equation told me to square it, so I did. This square. Then your minus 2 followed by the x, but now x is negative 2 plus the 4. Now we simply have to simplify this, so I will start by raising negative 2 to the power of 2. Negative 2 to the power of 2 is positive 4, so 3 times 4 minus 2 times negative 2 plus 4. The next thing we will do is multiplication, so 3 times 4, that's a 12. Negative 2 times negative 2 is a positive 4 plus another 4, and all in all it gives me a 20. So your answer is f of negative 2 equals 20. Sometimes I see students trying to get the f by itself. You should not and cannot get that f by itself. F of negative 2 is one piece. What this means here is that you have a point, and in that point, your x was -2, and the y was the number that you found was 20. It's not an equation that you need to solve for f. Let's try another one. So this next question gives you a function g of t equals absolute value of 11 minus t. And it asks you to find g of 3 and g of 24. So in the first case, the t becomes a 3, and then in the second case we start over and becomes a 24 in this same expression, the absolute value of 11 minus t. Let's go ahead and replace t with the 3. So absolute value of 11 minus 3, well, 11 minus 3 is an 8. Absolute value of 8 is 8. You're done. G of 3 equals 8. Again, this is just a point with coordinates 3, 8. It's not an equation to be solved for g. Now for g of 24, we're going to do the same work. Absolute value of 11 minus 24. 11 minus 24 is -13. And absolute value of any number, including negative numbers, is always positive, so it's just the 13. G of 24 is 13. If I ever asked you to write it as a point, you would write 24, 13. Here's a picture of a function. It's this right here is your graph of a function. And the question is asking you to find two things. The first thing that it asks you to find is k of -2. Keep in mind that what this means is your x is -2, x is -2, and k of -2 is the y when x is -2. So find y. You have to go along your graph like this and find a point on that curve where x is -2. And at this point, I'm going to make it blue, your x is -2. What is the y? Looks like y is +3. So k of -2 is 3. Again, you found the y if x was -2. The second portion of the question is backwards. It gives you y. K of x equals -3, that's the y. You need to find the x. So you need to find the point on the curve where y is -2. So y is -3, find x. Y is -3 right here. That's your -3. What is the x of this blue point? It's 1. So x equals 1 if k of x equals -3.